you, Anupam, please.
Okay, so I welcome once again you all for this poster session. There are basically 18 posters in this session, and therefore there is only 5 minutes for each poster, and there will be no question answers because we have time limitation. Okay, so straightway I think we should start this because we have to meet the timeline also. Okay, so the first poster is this is by Mr. Mohan Kumar, Dr. Sailesh Agarwal, Dr. Anu Faruqi, and Dr. Hassan Ali. The title of the topic is the impact of atmospheric carbon dioxide and delta 13 carbon values and instrumental index. Observation from industrial and non-industrial plants. So I think Mohan Kumar is presenting.
Please,
yes, sir.
height go over. Yeah.
Okay, so please start.
Good afternoon to everyone. My main work is focus on the how plants effect on the elevated CO2 concentration, because it is well known after the industrial evolution, the atmospheric CO2 concentration is very rapidly increases. And what we actually want to do in this study, how this elevated CO2 concentration react on the plant community. And we have chosen a transit from Pilibhit to Haldwani. From 5 locations we have selected naturally plant occurring, and including one industrial area where the very much industries are in progress, and basically they are using the fossil fuel burning. So this sites we have also collected the plant samples, and randomly we have chosen 5 plant species. These are Agarika indica, Seth habiata, Tectona grandis, and Mangifera indica, and E. globulus. So because these are very common species and available allwhere in our transit, and we are also measuring the isotopic values of these plants and seeing a similar trend following a pattern, and all the plant species showing a sudden drop in delta C13 values in the location 3 that is identified as an industrial site. Here we get the 2.6 to 5.6 per mil lowering in the delta C13C values. And to identify this geochemical observation, we also measuring some physical parameters, that is the stomatal index and epidermis cell density. And we also interestingly found that the stomatal index values also very lower in the industrial area, because in the industrial area the fossil fuel burning contribute the lighter carbon isotope in the atmosphere. So this concentration affect the delta C13 values in plant species, and also availability of a large amount of carbon dioxide in the atmosphere. The local plant community need to available very much abundant of carbon dioxide, so they develop the adopt the physical conditions and reduce the number of stomata per unit area. So the stomatal index value lower in the industrial area, and this is our final conclusion. And we also measuring the intra-leaf variation, and these are showing the intra-leaf variation very homogenized, because only 1 per mil around variation available. So they can be used for overall vegetation and climatic interpretation, and anthropogenic CO2 emission yielded enriched lighter carbon isotope in the atmosphere. So this effect on the delta C13 of plants, and also the increased CO2 concentration in the atmosphere, lowering the stomatal index. So this is our basic study. Thank you
for your presentation. And now we'll move on to next presentation, that is by Dr. Mayank Shekhar and other group scientists are Dr. Trina Bose, Dr. Anurag Kumar, and Avinash Mishra. The title of the poster is Trading with Data from 4 Agriculture Drought-Prone Districts of Central India.
Thank you, sir.
So over to Mike.
Thank you, sir. Good afternoon, all of you. I'm going to talk about the trading data from 4 agriculture drought sites from central India. So here we have presented a new trading data set, data chronology gathered from Tectona Grandis. And objective was to understand its association or relationship with the monsoon or large-scale tiny collections with the other atmospheric circulations. Considering the literature, the present study is the pioneer attempt to develop a trading chronology of teak from Bundelkhand region. As we all know, the Tectona grandis is native to South and Southeast Asia, mainly India, Bangladesh, Indonesia, Malaysia, Thailand, and etc. But now it's also cultivated in African country. And the habitat of teak is very variable. It ranges from 500 to 5,000 millimeter. So it's also represent dry element to wet element, wet conditions. So we have collected 4 trading samples from 4 districts of Bundelkhand region, 2 from Sagar and rest are from Damoh and Panna from Bundelkhand region. A little bit about the methodology. We have mounted the tree core on wooden frame and polished the upper surface so that cell can be visualized under the microscope. We measured the cell followed by the standard dendrochronological methods, and then we cross-check our data set using different softwares like Opheja and Anston. Besides this, we have also attempted to develop another chronology based on empirical mode decomposition. Basically, this is a frequency distribution based on different signals. So here we have developed 3 frequency graph, and that are moderate, high, and low frequency. Further, we have established tree growth climate relationship based on these frequency as well as raw trading chronology. So for the climate relationship, we used a common climatic period 1948 to 2015 between residual chronology and empirical mode decomposition with soil moisture, precipitation, and temperature for the window of previous year's October to current year September. We observed that the growth of tree is significantly positive with the monsoon or winter soil moisture. And this is only with the empirical mode decomposition. So we can say that with the moderate decompositions, moderate frequency can have a signals of climatic signals in frequency analysis. Further, we have also analyzed wavelet analysis to understand the frequency and periodicity. We observed 2 to 5 years of frequency domain during 1920 and 1980. Similar results also observed in Himalayan region by different worker, and they have correlated with the INSO variability. So in conclusion, we have developed a trading chronology which is ranging from 1896 to 2019. Between 1950, 1970, and 1980, 1920, and 29, we have a low and decline tree growth. And as we all know that the rainfall in Bundelkhand is declining since 2004, 5, or 6, 7, or 9, 10. The tree growth also decline in synchronization with the declining the rainfall pattern. It is clearly evident that in last 30 years, the normal rainfall year is also reduced, as well as moderate to severe drought are increasing. So in this analysis, we observed that the frequency of moderate empirical mode decomposition reveals response to the climatic conditions, and the wavelet analysis shows the INSO variability. And teak has a relationship with the monsoon variability in this region. Thank you.
Okay, thank you, Mayank, for the nice presentation. Now we'll move on to next presentation, and
there are some questions in the chat box. Please, Mayank, you can answer them, please.
Okay, yeah, this is because we don't have any question answer session. So those who are looking for some clarification or some questions or query are there, they can put their questions in the chat box, and the respective poster presenter will answer those queries. Thank you. So the third presentation of poster presentation is by Ms. Rachna Subha, and the other group members are Dr. Ravi Rangarajan, Professor Prasanjit Ghosh, and Professor Jayanto Raut. The title of the poster is Understanding the Isotopic Record of Secondary Cave Carbonate Deposits Used for Paleoclimate Reconstructions. So over to Ms. Rachna Subha.
Okay, thank you very much. Good afternoon, everyone. So as we have seen in the morning session too, like Speleothem is very highly regarded as a good archive when it comes to studying past climate, especially the Pleistocene. But we've seen that solely depending only on the oxygen isotopic record and the delta 13C isotopic record can sometimes lead to erroneous interpretation. So for this particular case study, I have used the Sandai cave, which is very close to Maulo cave and Washikhar cave. Maulo cave, as we know, has been extensively studied, and it has been well established that the precipitation of the cave carbonate is a direct representation of the monsoon rainfall. And so is the when we want to project it back into climate, we've seen that yeah, it works. So that is a significant representation of how the ISM has varied over the past few years, resulting in a new Meghalayan age also. So in this region, I found another cave which had a completely different isotopic signal, as you can see. So there was around 2 per mil, more than 2 per mil, more than 2 per mil variation in the isotopic composition of the carbonate. And this leads us to further question as to, can we solely depend only on oxygen isotope for reconstructing past climate? Though our sample has low resolution compared to the other samples. So as you can see in the poster, we have compared it with the published data of Momlo cave and a nearby Washikhar cave, which is in the same area. Our cave showed a very enriched delta 18O value, and that could have led, if we would have solely depended only on this particular cave's data, we would have misinterpreted it. Like we would have said that it was much warmer. But understanding cave dynamics, so what we suggest in this paper is, like, though 18O is highly used, we need to depend on other kind of isotopic tools like clumped isotope or maybe fluid inclusion isotope to better understand, because this kind of case report has been not only in like within the same cave also the speleothems may show variations within the same area, the same cave, the speleothem records may show variations. But the other interesting fact is, irrespective of showing variation in the absolute 18O value, this particular cave has been able to record the Roman warm medieval period, as we can see in the other figure out there. And I have correlated it with other published data, which also say that yes, the Indian subcontinent and the other archives and proxies used from those archives did show a warmer Roman medieval period during 2000 years ago. So yeah, the conclusion is that solely depending on oxygen isotopic values of carbonate is not entirely reliable. And though we may not get the absolute value, we can go to other measures or use other geochemical tools and techniques so that we can quantitatively also, not just qualitatively, but quantitatively interpret past climate. Thank you.
Okay, thank you, Ms. Rachna. Now we'll go for the next poster presentation, and this is by Adarsh Thakkar. The other group members are Madhvi Dhabi, Anil Chauhan, Gaurav Chauhan, Rakesh Bagora, Naveen Chauhan, Anil D. Shukla, Subhash Bandari, and Professor M.D. Thakkar. The title of the topic of the poster is Mid-Late Holocene Climate Reconstruction from Coastal Dunes of Western Kutch and Implications for Sea Level Change, Kutch, Western India. So over to others.
Thank you so much. Good afternoon to everyone at IQC and moderators of the session. I'm Adarsh Thakkar, PhD student at Kutch University. And today I'll be presenting the findings of our research titled Mid to Late Holocene Climate Reconstruction from Coastal Dunes, published in Quaternary International, September 2021. So the present study is undertaken on the eastern coastline of Kori Creek in the peripheral region of Western Kutch. So we can see stabilized linear dunes in the first image. The area is known as the Pinjorpir area, which is close to Narayan Sarovar. Dunes are trending northeast, southwest in accordance with the wind direction, and they lie over tertiary formations. The dunes documented in the study consists of a 10-meter section in the coastline area. Currently, the dune face has been eroded and the section is exposed. So we have studied the area, the geomorphology of the area, and created geological and bathymetric maps. The dune stratigraphy has been reconstructed based on field observations. We have done major and trace element availability of sediments to get the weathering and aridity indexes. We've also done grain size analysis. So and the OSL dating of the sediments. So I'll take you through all of it. So as you can see, we have taken two samples from two locations in the dune section, and then in the image down below we have done the grain size analysis. Now this grain size analysis is of the coastal dunes and of the inland dunes. So the dots you can see in the blue are of the coastal dunes, and the dots you can see in the red are for the inland dunes. So what I've done is we have done for 4 parameters: kurtosis, skewness, mean, and we have done 6 cross plots for them. And what we have found is there's not major difference between the coastal dunes and the inland dunes, the properties of the sediments, and whatever difference can be explained through it's because of the grain size difference, which can be explained from the distance of the coastlines. Next, we have done CIA and TIL and all of these major and trace element analysis, where we find out the weathering indices. So based on the results of the analysis of the dune sediments, they have been dated from 4.3 to 4.8 Ka, and the present dune sediments fall in the same time frame as the 4.2 Ka, which is considered as a drought event. We have also done a comparative analysis of climate and sea level studies across the globe, which you can see in the last image. So several studies have shown a drop in the sea level during the time period, and also a presence of a cold and dry climate. They don't necessarily have to be linked, but this is what is observed. And so based on the ages of the sample and the current erosion of the dune phase, we can assume that the Kutch coastline was exposed due to the lowering of the sea level, which resulted in favorable conditions for the formation of coastal dunes. And based on the tectonic uplift of the Kutch mainland, the tertiary bed was also below the sea level at that time. So if the sea level were higher than the present day, the dunes could not have been formed. So since there are two theories of dune formation, one attributes to a regressive sea regime and one to transgressive sea regime, here we have gone with the sea regression as for the formation of coastal dunes. Thank you.
Okay, thank you, Adarsh. Now we'll move to next poster presentation, that is by Anup K. Singh and the other group members are Professor Bahadur S. Kotlia, Dhiren Kumar, Professor Dhupsen Singh, and Pawan Kumar Gautam. The title of the presentation is High Resolution Precipitation Variability over Northwest Himalaya from 4 to 1.9 Ka BP, Impact of Indian Summer Monsoon and Indian Winter Monsoon. So over to Anup.
Okay, good afternoon all respected researchers. My poster is based on the cave record. This cave record from Pithoragarh, Mau Himalaya, Uttarakhand. We collected a 41.5 centimeter long stalagmite from this cave. The entrance of the cave is very narrow and narrower at the end, and this is good for isotopic equilibrium. First of all, we slice this stalagmite into two parts, one for the uranium thorium dating and second for the isotopic analysis and for mineralogical composition. Then we obtained 6 uranium thorium dates from this stalagmite and 415 isotopic samples. This stalagmite sample covers a time span of 4 to 1.9 kbp. The present sample is mainly consists of aragonite and only two portions. The upper half, two portions, is composition of calcite. Based on the delta 18O and 33 isotopic analysis, we get 5 major drought events. These major drought events are 3.4 kbp, 3.2 kbp, 3 kbp, 2.5 kbp, and 2.4 and 2.1 kbp. The delta 18O values have high fluctuation from -4 to -10 per mil, which reflect that two monsoon sources are active in the Himalayan region, that is ISM and IWM. And finally, when we conclude this, we compare delta 18O values with the Indus River discharge and found that the drought events from 3.7 to 3 kbp contributed to the gradual decline in the Harappan civilization. And this drought event at peak at 3 kbp. In addition, Indian winter monsoon is responsible for the Rabi crop production, and Rabi crop decline in the Indian winter monsoon. Rabi crop production is the main reason for the demise of Harappan culture, and this is the main conclusion of this poster presentation.
Okay, thank you, Anup, for this nice presentation. And now we move on to next poster, that is by A.S. Yamuna Sali, A.K. Warrior, K. Sandeep, Bharti Sharma, and Professor R. Shankar. The title of the poster is a 1600-year environmental magnetic record of paleo monsoon variability from a coastal lake in Karnataka. So over to Yamuna Sali, please.
Thank you, sir.
Okay, change the poster. Yes.
Good afternoon. I am Yamuna Sali AS, a CSIR Junior Research Fellow working under the guidance of Dr. Anish Kumar Warrior. Here I am presenting our work carried out on the lake sediments from the coastal Karnataka to study the paleomonsoonal conditions of the region. The title of my presentation is a 1600-year environmental magnetic record of paleomonsoon variability from a coastal lake in Karnataka. Southern India is becoming more and more vulnerable to many extreme climatic events for the past few years. Limited high-resolution records in the region hinders the comprehension of underlying factors for these sudden changes. This study attempts to reconstruct the past changes in the Indian summer monsoon in coastal Karnataka, southern India. For this, we collected a 154 centimeter long sediment core from Lake Ramasamudra. Top 35 centimeter of the sediment core was lost during sampling due to high moisture content. The core was subsampled at a 0.5 centimeter interval. 5 samples from uniform depths were carbon-14 dated and environmental magnetic measurements were done for all the subsamples. The AMS carbon-14 dating gives a record of 1586 years, that is from 2037 to 451 calibrated year before present. This period encompasses 3 significant global climatic intervals: the Roman warm period, the Dark Ages cold period, and the medieval warm period. All the concentration-dependent parameters, that is KLF, KFD, KARM, and SARM, show a similar and a decreasing trend from the bottom of the curve, that is from 2037 to 451 calibrated year before present. It represents a weakening of the monsoon during this period. An abrupt and anomalous decrease in the values of concentration-dependent magnetic parameters can be seen from about 600 calibrated year BP onwards. The KLF value is the lowest for this interval. This period witnessed the weakest monsoon rainfall from 2037 to 1600 year before present. That is the period corresponding to Roman warm period. The monsoon was the strongest, represented by the high KLF values. During the interval 1500 to 1050 calibrated year BP, a steady decrease in the concentration-dependent magnetic parameters in response to a weakening monsoon is observed. From 1050 calibrated year BP onwards, the concentration-dependent magnetic parameters keeps on decreasing. It represents further weakening of the monsoon. Chiarum to KLF, Chiarum to SIRM, and SIRM to KLF are the parameters for magnetic grain size. KFT percentage indicates ultrafine superparamagnetic grains. The RSL sediments show low values of IRM 20 millitesla to ARM and high values of KFT percentage and KIRM to KLF. Therefore, the magnetic grains present in the RSL sediments are mostly stable single domain and ultrafine superparamagnetic, indicating a relatively stronger intensity of pedogenesis in the catchment with the increased monsoonal conditions. The magnetic mineralogy of the RSL is mainly composed of magnetite, as indicated by the high values of the S ratio. The spectral analysis of the magnetic susceptibility data of the RSL was done. It identifies the periodicities in data. Periodicities of 526, 226, 102, 90, 81, and 67 years were obtained, most of which are of solar origin. This indicates the influence of the solar forcing on the Indian summer monsoon. So we concluded that the magnetic mineralogy of the lake is mainly composed of magnetite, as indicated by the high values of the S ratio. The magnetic grains present in the sediments are mostly stable single domain and superparamagnetic, indicating a relatively stronger intensity of pedogenesis in the catchment in response to enhanced monsoonal conditions, and periodicities of 526, 226, 102, 90, 81, and 67 years, which are of solar origin, indicates the influence of the solar forcing on the Indian summer monsoon. Thank you.
Okay. Thank you, Ms. Yamuna Sali. Now we'll move on to next poster presentation, that is by Varsha Rawat and Suman Rawat. The title of the poster is Vegetation and Climate Changes Based on Pollen Record from Garhwal Himalaya and its implication on ENSO influences during the past around 2000 years. So, Ms. Rawat, please.
Yes, thank you, sir. I am Varsha Rawat and I am a PhD student from Wadi Institute of Himalayan Geology. I am presenting pollen records of past 2000 years from Bedni Kund Lake, which lies in the alpine meadow at the altitude of around 3500 meter in the Chamoli district of Uttarakhand. Pollen analysis was done along with the other multi-proxies such as TOC, environmental magnetism, grain size, and stable isotopes. The pollen trends in our which we get in our pollen record are matching with the other proxies which has been already published. So pollen assemblage for the last 2000 years is presented in figure number 3. I will be summarizing the major pollen changes that happened during this time. In zone 4, from 1865 to 1000 Calier BP, ISM was weak as suggested by the low total pollen count and also the low arboreal pollen to non-arboreal pollen ratio. Overall decrease in vegetation suggests that adverse climatic conditions were prevailing in this time due to the weak monsoon. And during the medieval climate anomaly from 1000 to around 800 Calier BP, high total pollen concentration along with the increased tree-line taxa such as ABs, Betula, and Ericaceae suggest that increase in overall vegetation and advancement of tree line under warm and wet conditions, indicating strong ISM during this period of MCA. And during Little Ice Age from 500 to around 335 Calier BP, very low pollen influx along with low marshy taxa and high desert steppe taxa suggest dry conditions during the weak monsoon during the LIA. We compared these ISM records, especially during the MCA and LIA, with the ENSO records, which are based on SST, sea surface temperature, and also the ENSO records based on precipitation records from the tropical Pacific. SST-based ENSO records, which are in graph G and H in figure number 4, suggest that La Nina was prevailing during MCA and El Nino was present during the LIA, which goes well with our strong ISM during MCA and weak ISM during LIA in our ISM record. However, the precipitation-based ENSO records in graph E and F suggest that La Nina was prevailing during LIA and El Nino was prevailing during MCA, which is opposite to the ENSO reconstructed from SST in tropical Pacific and is also contradictory to the inverse relationship already established between ENSO and ISM. These discrepancies in ENSO records might be because, other than the ENSO, position of ITCZ is also a crucial factor for precipitation over tropical Pacific, as the studies have already shown that monsoon and ITCZ variations have influenced the tropical hydrology in tropical Pacific in the past 2 millennia. And the influence of solar radiance and position of ITCZ for the last 2 millennia is also suggested by highly correlation of ISM record, ISM record with the northern hemisphere temperature variability. So, other than this ITCZ variation, we also have to consider the ENSO signal in tropical Indian Ocean to fully understand the relationship between the Pacific Ocean, Indian Ocean, and ISM. So, more research is needed. First, we have to reconcile the contradiction between SST and hydrological ENSO records so that we can examine the accurate relationship between ENSO and ISM. Thank you.
Okay, thank you, Ms. Varsha. Now, once again, those who have joined a little later, I would say that there is no question answers in this session. So those who wish to ask anything, they may write their questions, queries, or comment in the chat box, and the respective speaker will answer the query. Okay, so moving on to next presentation, that is by Dr. Swati Tripathi and Dr. Sadhan Kumar. The title of the poster is Modern Pollen Representation of the India, a comparative assessment of bat guano from conventional soil and moss substrates. So over to Swati, please.
Thank you, sir. Good afternoon to everyone. So the title of my today's talk is on your screen. So we started this study with a question that is bat guano a potential pollen trap? Just a comparative assessment from conventional soil and moss substrates from one of the Meghalayan caves. So as you all know that Meghalaya is known to have many caves, and this is critical for pollen studies in this region, as you know that the cave floor, it provides better pollen preservation in comparison to the open sites due to less chance of oxidation. So the studies from the guano deposits from the USA, a recent study revealed that there is an immense potential for pollen in guano piles to be used for the study of past environment. So the paleological study of surface soil and sedimentary soil sections in Meghalaya, it is a very tedious task. It's not so easy due to high rainfall and the consequent soil erosion of the hilly terrain, along with annual forest fire that is naturally or human caused, or due to the extensive rocky surfaces along with the scanty of lakes, swamps and wetlands. So we have two main objectives: to investigate the potentiality of the bed guano sample from the cave floor and to check the near proximity of bed guano samples to surface soil and moss cushion in terms of modern pollen precipitation and significance in the Garo Hills of Meghalaya. So as you can see on your screen, there are some statistical results. So the PCA analysis, it shows that the bed guano samples, that is BGS, they are falling near to the forest floor sample. That is the pollen trapped in the bed guano piles. They are very close to the pollen which we are retrieving from the forest floor. That is the surface soil as well as from the moss cushion samples. At the right hand side of the screen, you can see the palino assemblage. We are getting the typical pollen assemblage of that region, that is representing the vegetation of that region, which is tropical mixed deciduous forest. Interestingly, you can see the clumps of Duabanga pollen. So when we are getting the clumps of typical tree taxa from the guano samples, that which sometimes we are not getting in the surface soil. So that is exactly that is showing that the bed guano samples, they are the potential substrates for the modern pollen precipitation. The second thing, you can go through the field photographs also. There you can see the bed guano samples on the forest floor. Then there is a secondary forest growth in that region, that is the melastoma pollen and the Erica catechu also you can see. So the main thing is that from the pollen assemblage, there is a record of the secondary forest formation and anthropogenic activities, that is the presence of cereal and melastoma pollen. The cereal pollen, as you all must be aware about, that the pollen which having the monoporate aperture, and I have kept the two pollen grains in the pollen assemblage slides also. So that is showing the anthropogenic activities along with the erica and citrus pollen in the studied pollen assemblages. So the study, it confirmed that bed guano deposit in caves when available should be considered as reliable data source, which could precisely be utilized as a part of interpretation of the modern pollen precipitation and further the paleoecological analysis. Thank you very much.
Okay. Thank you, Swati, for this nice presentation and finding a new archive for studying. Now moving on to next presentation, that is by Parth Shah, Ankit Yadav, Ilaria Mazzini, James Russell, Nicholas Waldman. The title of the poster is Late Holocene Climate Changes Reconstructed from the Lacustrine Sedimentary Record in the Southern Yemen. So over to Parth Shah.
Hello everyone. So I am Parth Shah. I'm working on lake sediments from Yemen as a part of a PhD project in University of Haifa, Israel. So the lake Ghail al-Bazal, which I'm working on, is situated in the southern margins of Arabian Desert. This particular region is climate sensitive zone that can respond to a small scale hydrological changes. The climate of this region is arid, and mostly the rainfall this region receives is during March, April, and May through Red Sea True, and some of the rainfalls moisture is also received during Indian summer monsoon. There are very few records from this particular region. There are some, but they have very less continuity, or they are not have a high preservation, or the chronology is not very well established. So the major objective of my work is to reconstruct the sentinel scale climate changes in this region, and also to increase the spatial coverage from this particular region to understand the monsoonal changes in this particular, to understand what were the past major monsoonal zones in this particular affecting this region. So for that, we retrieve 3 sedimentary core from this particular paleo lake. And the chronology of this particular lake is based on 5 radiocarbon dates. We combine these 3 cores into one composite core, and the age goes to like 1200 years, and all the ages are stratigraphically consistent. About the methodology, we initially started with the non-destructible methods like XRF scanners, magnetic susceptibility. Then we moved over to destructive analysis like TOC, Ostracods, grain size, biomarkers. So just to give you just about the results, from the XRF, we found out the calcium is orthogenic. So during lower lake level, gypsum is precipitating, whereas titanium and aluminiums are coming through Wadi influx in the region. And during the higher digital influx, we are seeing the increased TOC values. And the lithology of this particular core is mainly characterized by silty fractions with the minor incursion of clay silt and sand in the core. Here we also, based on the grain size results, we see we identified 5 end members. Among them, 3 major end members are correlated with the physical processes. End member 1 is associated with the Wadi influx, EM2 with the Aeolian influx, whereas EM3 is associated with the moving of shoreline due to changes in the lake level. We also did an Ostracod analysis, and we found 3 major species in there: Paracyprita, Condona, and all these species are like floating species. And based on this all multi-proxy results, we identified major zones where we can see the precipitation changes, and we identified 2 major events from this particular lake core: medieval climate anomaly and little ice age. Medieval climate anomaly is being characterized by hereditary influx with the increased Wadi influx due to finer fractions. We also see the increased Ostracod abundance in this particular interval. Whereas in Little Ice Age, we see the formation of gypsum, eoprite formations, increased eolene influx, and we see the Ostracod abundance is decreasing in this particular intervals, and we see more juvenile ostracods in this particular phase. And we compared this result with the other regions also, like from Saudi Arabia to Kenya to tropical Africa, and we can see that like we are actually correlating with the other regions, that MC is wet and LIA is dry. And we are actually also correlate our result with the solar forcing, and we can see our data is showing the same trend as the solar forcing. So we are like telling that the cause of MC and LIA for this particular region can be associated with the solar forcing. We have recently published one of this paper in Frontiers of Earth Sciences. You can see in the reference, or you can scan the QR code. And if you have any further question, I am here to answer. Thank you very much.
Okay, thank you, Mr. Path. Now moving on to next presentation. This is by Dipti Mai Bera, Praveen K. Mishra, Pandurang Sable, Sharmila Bhattacharya, and Dr. Anup Ambli. Okay, the title of the poster is The Late Holocene Culture and Climate Dynamics in the Indian Summer Monsoon Riyadh. Over to Dipti.
Thank you, sir. Good afternoon, everyone. My name is Diptimai Behra. I am in the third year of my PhD program at IISER Mohali under the supervision of Dr. Anup Ambli. The topic of my poster presentation is Late Holocene Culture and Climatic Dynamics in the Indian Summer Monsoon Realm. The motivation of this study lies in the cultural findings reported from Sina River Basin, which majorly includes pottery and Bengal artifacts. And very few agricultural evidences are available from this region, and the agricultural evidences available from this region also are concentrated to crops which are grown in arid or semi-arid climate. As we know, the availability and accessibility of resources are considered as the key component influencing the human settlement patterns and cultural activities. Climate has a very crucial role to play in the availability of resources, making it pertinent to understand the climatic conditions in order to understand the cultural dynamics of a region. So this brings me to the key objectives of our work, which is first to reconstruct the paleoclimate of this region through multiproxy approach, and then to integrate the archaeological findings with these established climatic records to understand the cultural response to these variability. The age of this studied sequence was established through OSL and C14 dating, which ranged from 7.5 kiloyears to 945 years. The archaeological findings were confined to the topmost unit, litho unit of the sequence. Hence, high resolution C14 dating was employed to constrain the age of this litho unit, which ranged from 1.5 kiloyears to 945 years before present. The multiproxy approach, which included grain size analysis and geochemical analysis, were employed for paleoclimatic reconstruction of this region, of the studied region. The gradual decrease in the mean diameter of the particles suggested decrease in energy condition of the depositing systems. The elemental ratio is supportive of this grain size distribution, as we can see in the figure. The declining elemental concentration is also suggestive of decrease in chemical weathering. Together, these proxies depict that there was a gradual decline in precipitation towards late Holocene. Supportive information regarding acidification in central India were also compared from different studies, which also suggest that similar intensified aridity condition prevailed in this region during the late Holocene period. When we correlate these climatic understanding with the cultural findings, it can be suggested that the drier climate was not suitable for the habitant residing in this region during that period to rely on agriculture for their survival and sustainability. Therefore, instead of switching or opting for agriculture as their primary mode of survival, they tried to develop various different skills uh, and craftsmanships in order to survive and sustain as a settlement. So therefore they encourage trading as their primary mode of sustainability. Also, due to this intensified drying climate of this region, major declining in vegetation might have occurred. This decline in vegetation and clearing of forest naturally might have given rise to new routes for trading, and also these new routes of trading might have also enhanced the mode of migration and relocation of the habitants. And hence we concluded that climatic changes have a very key role in modifying the cultural dynamics of a particular region. Thank you very much. You can ask questions if any.
Okay, thank you, Deepti. Now we move to next presentation, and that is by Ms. Meenakshi. The persons are Rakesh Chandra and JP Srivastava. The title of the poster is Organomolecular Record of Warm Periods from Late Quaternary Lowest Paleosols from Dilpur Formation, Kashmir. So over to Meenakshi, please. Meenakshi, are you there?
Hello, am I audible now?
Yes.
Am I audible now, sir?
Yes, Meenakshi, please go ahead.
Okay, thank you, ma'am. Thank you, sir. Good afternoon to everyone. I'm Meenakshi from University of Ladakh. I'm presenting my work on organomolecular records of warm periods from the late Quaternary Lowest Paleosols from Dilpur Formation, Kashmir. Based on the isotopic composition studies over the Lowest Paleosol sediments, Krishnamurthy et al. 1982 and Dar et al. 2015 inferred cold climate with low CO2 pressure and water stress conditions. Climatological investigations by Meenakshi et al. 2020 revealed 3 stadials and 3 interstadials recorded in these Lowest Paleosol sediments. Cold periods are well defined by the presence of Lowest layers among the Paleosol layers, as well as the cell parametric changes found in the elite and chloride clay minerals, but relevant information for the warm period still needs to be acquired. So the study area lies in the northwest southeast trending Kashmir Valley, intermountained by Great Himalayan Range and Pir Panjal Range on either sides. Valley comprised of complete stratigraphic record from Archean to recent with Kareva group on the top. And on the top of Kareva group, there lies the Dilpur Formation, comprised of interbedded Lowest Paleosol profiles. The Shankarpura section present towards the Pir Panjal range was selected for this study, which contained 12 Paleosol and 2 Lowest layers. A total of 26 samples were collected from the Shankarpura section, which were analyzed for presence of total organic carbon, from which only 5 samples contained more than 0.5% of organic carbon. So these 5 samples were further subjected to separation for analkane, fatty acids, and polyaromatic hydrocarbon frictions. These frictions were further analyzed using GCMS to get their abundance, and these results shows the presence of N-alkanes dominated by C27, C29 and C31 long chain alkanes, which infer their derivation from the trees, shrubs and grasses respectively. In the first and fifth Paleosol layer, from the middle diagram, Paleosol layer showed the dominance of trees and shrubs over the grasses, whereas third, fourth and 11th layer of Paleosol shows dominance of grasses over the shrubs and trees. The low odd over even predominance values suggest the degraded soil organic matter in Kareva Paleosols, and from the bivariate plot after Sheffer et al. 2016, it suggests more degraded soil organic matter in the first Paleosol layer than the older layers. While formed from the fresher plant material, which is evident from the lower value of the expression on the y-axis of bivariate plot. Ternary plot for carboniferous deciduous and grass material also shows the data plot's affinity towards the carboniferous type of carboniferous type of plant material as compared to grasses and deciduous. These observations, when combined with the radiocarbon ages as well as the climatological investigations reported earlier from these Loess Paleosol sediments, give a complete understanding of for the 5 Paleosol layers, which are where the organic matter present in these layers was affected by the effect of overlying and underlying Paleosol layers. The C31 C27 ratio shows grassland vegetation during the cold periods, whereas tree type of vegetation dominated during the warmer periods, which further supported by the presence of leaf wax derived C24 long fatty acid. The warm periods were marked by 1st and 5th Paleosols, whereas the 3rd, 4th, and 11th Paleosol layer shows the effect of cold climate recorded in the preceding and successive layers. So the climatological data also seconds all these observations from the organomolecular records. Thank you.
Thank you, Nashi. Now, move on to next poster presentation, that is by Shravi Agrawal, Sunil Kumar Shukla, Pradeep Srivastav, and Professor Yashpal Sundaryal. The title of the poster is Diatom-based water table reconstruction during middle to late Holocene in high altitude Himalayan peatland, India. So over to Shravi.
Thank you, sir. Good afternoon, all. Myself, Shravi Agarwal, is here to present a study based on the diatom study for water table reconstruction during middle to late Holocene in high altitude Himalayan peatland. Peatlands play a crucial role in assessing both short-term and long-term changes in the atmospheric carbon sink due to their potential capacity of microorganism hosting and organic matter decomposition. Diatoms has been considered to be the important organisms in the peatlands due to availability of sufficient amount of water and nutrients. And also water table has been considered as the most correlated variables for growth and abundance of diatoms in the peatland. Despite the sensitivity of both peatlands and diatoms to environmental changes, the paleoclimatic reconstructions using peat sequence in high altitude Himalayan regions are rare. So here we present a total diatom abundances and relative abundances of diatom species preserved in a 5.2 meter long peat sequence, which is shown in figure 1 at Kedarnath Shrine to reconstruct the environmental changes over the mid to late Holocene, that is the last 8,000 years to present. To perform the methodology, the diatoms were extracted from the peat sediment samples, nearly a total of 127 samples, providing a time resolution of around 50 to 100 years using standard methods of slide preparation and diatom counting. The principal component analysis and cluster analysis were applied to the diatom data to identify the statistical significance of the data. And our results and the data on peatland diatom abundances shows that the peatland diatoms can be used to reconstruct water tables in the Indian Himalayan regions. And a total of around 122 freshwater diatom species were recorded over the last 8,000 years. And the principal component analysis applied to all diatom species yielded 16 main species that significantly contributed over the last 8,000 years. And among those, the two species, namely Brachycera eponina and Tabellaria flocculosa, were found to be the most abundant among all the species over the last 8,000 years and are shown in figure 2. The 16 species that are yielded from principal component analysis, and the absolute diatom abundances were high during the 4 periods, namely 5,700 to 5,350 calendar years, 4,350 to 4,250 calendar years, 3,850 to 3,000 calendar years, and 1,700 to 950 calendar years before present, and therefore are characterized by higher water table. And on contrarily, the absolute abundances of diatoms were low to absent in the mentioned 4 periods, and most importantly, the 950 to 300 calendar years before present, and are therefore characterized by lower water table. The figure 4 and figure 5 summarizes the results of water table reconstructions, and the diatom abundances also showed correlation with the geochemical proxies, except for a few exceptions. And the figure 4 and figure 5, the vertical shaded regions shows the higher water table in the figures. And this shows that the geochemical proxies correlation with the diatom abundances shows that the reconstructed water table variations during mid to late Holocene in Indian Himalayan regions could be attributable to changes in rainfall intensity. And our data also correlated with the northern hemisphere solar insolation and ice rafted debris data of the North Atlantic. So here I could conclude that the first study to infer water table reconstructions in the Kedarnath peat reveals that the rainfall variations plays an important role in Indian high altitude regions. And the shorter growth cycles of diatoms could explain the low abundances of diatoms during the cold and dry periods. So the poor preservation of diatoms in the peatland during 950 to 300 calendar years before present could imply that the peatland is deteriorating and hence could be a substantial source of atmospheric carbon dioxide. So as a result, the present study invokes the need of in situ data monitoring for the Indian peatlands. Thank you.
Great.
Okay, thank you, Shravi. Now we move to next poster, that is by Priyanka Singh, then Dr. Mohammad Arif, Nawaz Ali, P. Manimaran, Sailesh Agrawal, Ruby Ghosh, and Dr. P. Mortakai. The title of the poster is a non-linear paleohydrology time series analytic study, an attempt to delineate the predominant influence of Western disturbance over Indian soil monsoon in higher central Himalayas, LGM. So, Priyanka Singh, please.
Thank you, sir. Hello. Okay. Hello, everyone. I'm Priyanka Singh, research scholar in Birbal Institute of Paleosciences. I'm working under the supervision of Dr. P. Murthikai. I'm here to present my poster, which has a specific scientific problem of my study area, and to solve that problem, what approaches I used, results obtained, and the conclusion arrived. Our study site is a relict proglacial lake situated at 4,000 meters above mean sea level in central Himalaya, Uttarakhand. This region is influenced by both the climate system, that is ISM periodic, and the non-periodic westerly disturbances. Our objective is to delineate both the climate system and their operating periods in the past. For that, we used a high resolution at 1 centimeter magnetic data using 400 sediment samples and generated paleoclimate time series using Bayesian age-drift model. The plot has age versus 9 magnetic proxy parameters. 3 less or non-correlated data, that is KLF, susceptibility, KIRM by SIRM for grain size, and S ratio for mineral G were selected using correlation coefficient for further analysis. RNA and RQA was done to check the climate regularity and dynamic transition and compared with the available records. Recurrence plot was constructed with using proxy data, that is susceptibility, by choosing appropriate embedding parameter, that is M is equal to 7 and time delay T is equal to 12 for our lake system. Similarly, using RNA, network plot was generated using visibility graph algorithm, and from network, a adjacency matrix is constructed, which is equivalent to recurrence plot. As we are not getting continuous parallel lines in recurrence plot, some patches also there suggest lake system has both periodicity and non-periodicity at different times. For understanding the dataset, a confidence interval needed. The values above or below that confidence interval is significant for any inference. On the basis of recurrence plot and adjacency matrix, 5 quantifiers are suitable. to address our objective. And these quantifiers are determinism for predictability, laminarity for intermittency, transitivity for regularity, DET by RR, that is dynamical transition, and for average path length for abrupt dynamical transition. And to understand in the plot, the green arrow for regularity, blue arrow for unpredictability, and red for the transition. So the result says that at 4Ka and 8Ka, the system was at transition. Then during 11.8 to 6Ka, 7.9 to 4Ka, the system become predictable. And during 11.8 to 8.2 Ka, 8.6 to 7.6 Ka, and 5 to 4 Ka, system was regular. And 13 to 11.8 Ka, and since 4 Ka, system become unpredictable. Also, PCA was done using nine magnetic proxy data, and results from PCA 1 axis and PCA 2 axis were compared with the available records. PCA scores 1 is most influensive, and that is visually matching with the available precipitation data by Herzog 2006. And the PCA 2 score, which is second significant data, matching with the temperature trend available by the Liu et al. 2020. So we can say the influencing parameters are precipitation and temperature for our lake system. We can conclude our study by saying transitions and predictability of the system are consistent with the available paleoclimate records. Also, Kumar et al. Differentiated Indian summer monsoon and westerly disturbance based on D-axis. Higher the D-axis, higher the westerly disturbance influence. Also, RQA and RNA have potential to delineate between westerly disturbances and ISM influence in the past. That's all. Thank you.
Thank you. Yeah.
Okay, thank you, Priyanka. Now we'll coming means more than 50% are over, and there are only 4 or 5 posters are left. So we are bang on time, and the next poster presentation is by K. Sandeep, and the other associates of this study are R. Shankar, Anish Kumar Warrier, and G.H. Arvind. The title of the poster is A Lacustrine Geochemical Record of Chemical Weathering Intensity and Rainfall During Holocene from Tropical Southern India. So over to K. Sandeep, please.
Thank you, sir. Am I audible, sir?
Yes, yes.
Okay, thank you, sir. This study is about, good afternoon to all. This study is about the geochemical record of the chemical weathering intensity and rainfall during the Holocene from tropical southern India. So the objective of this study is to determine the variations in the intensity of chemical weathering and provenance of lake sediments from Shantisagara Lake, which is situated in the Karnataka state of southern India. And the objective of this study is to reconstruct the climatic variability and chemical weathering intensity during the past 11,000 years. So an undisturbed sediment core of about 1.3 meter length was collected from the Shantisagara Lake, and it was subsampled at an interval of about 0.5 centimeter. The organic matter of the bulk sediment samples was used for the AMS C14 dating, and the various major and trace elements were analyzed using the ICP-MS facility after the digestion of the samples. So in order to decipher the metal, in order to decipher the heterogeneous influx, various metal aluminum ratios like potassium by Al, Na by Al, Fe by Al, etc. were calculated. And the indices of chemical weathering like chemical index of filtration and rubidium strontium ratio were calculated. And the data was analyzed using the statistical methods using the principal component analysis and discriminant function analysis. So the downcore variations of the metal aluminum ratio of K by Al, Fe by Al, and titanium by Al, and Zn by Al, they showed significant downcore variations, while that of P by Al, lead by Al, and sodium by Al, etc., they do not indicate much variation, and they indicated steady values. And also the C by chemical index of filtration values did not exhibit any variation, and they do not match with the metal aluminum ratios also. So the sediments have resulted from moderate to intense degree of chemical weathering, and they show very high compositional maturity. The discriminant function diagrams and Al2O3 by TiO2 ratios point towards a change from an intermediate source during the early and mid Holocene to a felsic one during the late Holocene. And the similar LREE enriched chondrite normalized RE patterns also indicate they indicate there is no significant changes. So regarding the chemical weathering intensity, the early Holocene phase was characterized by a moderate influx of fine detritalfaction with a peak around 10,500 Talliers BP. All of the metal aluminum ratios and rubidium strontium values indicate a peak during this period, which points towards a very high rainfall during this period. So the catchment area experienced moderate to high rainfall during this period. A fluctuating trend of terrigenous influx and chemical weathering is documented during the 8,000 to 4,000 Callier BP in response to variable rainfall. Then during 4,000 to 2,000 year Callier BP, decreasing rainfall trends are documented, but from 2,000 Callier BP onwards, a slight increase in the metal aluminum ratios are documented. So anoxic conditions were present during the mid and late Holocene periods, which was documented by Mn by Fe ratios. So overall, we can say there were slight variations in the metal aluminum ratios during the early, mid, and late Holocene periods, but there are no overall changes in the CIA or rubidium strontium values. Hence, in the tropical southern India, where there is intense chemical weathering is taking place, generally the metal aluminum ratios are found to be better indicators of terrigenous influx and rainfall in this region. So thank you all.
Thank you.
Okay, thank you, Sandeep. Now we are moving to next poster, that is phytoliths in modern plants from dry and moist deciduous forest of the western margin of Bengal Basin and implications in paleovegetation reconstruction. And this will be presented by Korobi Sakia, and the other group members of this study are Deepak Kumar Purva, Altaf K. Kabir, Ruby K. Ghosh, and Subir Bera. So over to Korobi Sakia.
Thank you, sir. Good afternoon to everyone present here. Today, I am Korobi Sakia, working under a PhD student working under the supervision of Dr. Ruby Ghosh from BSIP Lucknow. The topic of my poster can be seen on the screen. For the successful presentation of this work, we have collected 76 grass specimens, 168 non-grass texas, and 50 surface samples from dry and moist deciduous forest from the western margin of the Bengal Basin. As mentioned earlier by Dr. Ruby Ghosh in the previous session, that there is a good variability of mean annual temperature and precipitation in the western margin of Bengal Basin. So we have chosen this as the study area for the present work. In the figure 1, we can see that the sampling sites of modern plants, specimens and surface samples collected from the western margin of the Bengal Basin. And in the main objective of the study was to understand if the phytolith morphotypes can distinguish different vegetations, that is vegetation type, that is the closed forest, open forest, lake beds, or the grasslands within the two different forest types. And also to identify whether identify the governing climatic factors influencing the frequency of this phytolith morphotypes. So in the second figure, we can see the different morphotypes which have been retrieved from the plant specimen and the surface sample studied. And these are the in the first figure, we can see the grass morphotypes like bilobates, saddles, crosses, etc. And in the second one, we can see the non-grass morphotypes, that is the spheroid ornate types, various epidermal plates, acne epidermis, etc. So this data set has been subjected to RDA, the redundancy analysis, to show for understanding the relationship between the environmental variables and the surface soil phytolytic assemblages. And here we can see that the first axis, which is the dominant axis, is dominated by the climatic variable, that is MPWEQ, which is the mean precipitation of wettest quarter, and that is the summer monsoon precipitation. And here we can see also that the phytolite assemblages collected from the forest are more dominated in the first axis than, and as we go towards the left hand side, we see that grassland samples are more dominated. So from here we can conclude that the distribution of the different morphotypes which have been collected from different vegetation types or within the vegetation within the forest can be is mainly influenced by the summer monsoonal precipitation. And from this I can conclude by highlighting the significant findings by highlighting the significant findings that the phytolite assemblages which have been retrieved from different habitats are primarily influenced by summer monsoonal precipitation, and also that the results which from the present study can be used as a baseline while reconstructing the past vegetation and also the climate of the Bengal region. Thank you.
Great. Thank you.
Okay, thank you, Corby. Now we are moving to next presentation, and that is by Dr. Anjali Trivedi, and the other group member is Mohammad Ikram. Title of the poster is Vegetation, Climate Change and Human Impact in Central Ganga Plain during late Holocene. So, Dr. Anjali.
Hello, am I audible?
Yes.
Okay. Good afternoon, everybody. Today's my topic is vegetation, climate change, and human impact in Central Ganga Plain during late Holocene period. As everybody knows, the Ganga Plain is one of the largest alluvial plain of the country, abounds with a large number of potential extinct and extant lakes of varying dimensions. Interesting site that maximum lakes are situated in the proximity of the ancient settlement site. Appending with the archaeological information together with the paleological approaches is rewarding to reconstruct the very good paleoclimatic records of the Ganga Plain. Ganga Plain is geographically divided into the three parts, that is the Upper Ganga Plain, Middle Ganga Plain and Lower Ganga Plain. Upper Ganga Plain is from the Himalayan frontal front ridge to the Delhi Aravalli ridge, and Middle Ganga Plain from the Delhi Aravalli ridge to Rajmahal Hill, and the Lower Ganga Plain from Rajmahal Hill to the West Bengal and most part of the Bangladesh. Our study site, Bilind Kheda, lies into the Central Ganga Plain, and it is situated into the Hardoi district, which is far from about 77 kilometers from the Lucknow. On the base, it is situated. Actually, it is situated on an archaeological sites. So there was excavation was done by Professor D.P. Tiwari, and we got many potteries, antiquities, and bricks structures on the Bilind Kheda. And on that basis, they have divided the sites into three parts. That is Sunga Kushan period, Gupta period, and pre-medieval period. We have collected two trenches, one from the archaeological sites, one from the lake flank. And it is complete. It is this site is under the agricultural. Right now, the almost lake was covered by used by the crop as a crop field. We have also collected 8 surface samples for the recent pollen spectra description, which is very important part because on that basis we can say we can calibrate the past climate into the sediment profile. In the recent pollen spectra, we got that non-pollen pollinomorphs are more than the arboreal taxa. So, and in all the 8 samples, all the samples are dominated by the agriculture pollen taxa, like Poaceae, Chinoams. That shows this site is under the cultivation. And we have also the preliminary study of trench has been done, because we have 5 dates, and it's a 310 centimeter sediment core. These dates are from the 4.2 kilo year BP to 1200 kilo year BP. On that basis, we have model into the 4 division. First, the study revealed that the 4000 to 3900 year BP supporting open acacia dominant scrubby forest, and between 3900 to 2200 year BP amelioration in climate present at showing the invasion of the trees was started, and subsequently between 2200 year BP to 1200 year BP, the open mixed tropical deciduous forest developed under warm and humid climate condition due to a strong Indian summer monsoon. Since 1200 year BP onwards, the region was warm and relatively less humid, reflected by the open mixed tropical deciduous forest with reduced frequency of almost all the tree taxa. We can't deny the agriculture activities was also expanded in that area. So it could be a region to the exploitation of the tree taxa. Agriculture activities is witnessed throughout the core. Okay, thank you.
Thank you.
Okay. Thank you, Anjali. Now only 2 posters are left, and the second last one is by Dr. Manoj MC and his student Masood Kasar. The title of the poster is Decoding the Dynamics of Soil Erosion and Hydroclimatic Signals Using End Member Modeling Analysis on Southwest Indian Lakes. Over to Manoj.
Thank you, sir. You all know the lake deposit faithfully preserves the signals of local and...
The poster, yeah, now it's changed.
Yeah. Okay. Yeah. Thank you. The lake deposits faithfully preserve the signals of local and regional climate changes that are occurred since their formation. So during the transportation and deposition, different grain size classes are sorted and mixed by the different transport agents and gives rise to characteristic grain size distribution. So the natural grain size distributions are composed of dynamic subpopulations, that are those are the end members that were sorted by different sediment transportation and depositional processes. So this present study is, aims to infer the hydrodynamic conditions and their controls on sedimentation, soil erosion, as well as hydroclimatic conditions in the catchment of lowland and highland lakes of Kerala. That is, 2 lakes are selected. One is this Vegetation lake from the lowland, and another one is a highland lakes, that is Vagamon lake. And the sediment textual parameters from these 2 lakes exhibit significant fluctuation throughout the core actually. So this study provides an insight into the regional intensification of monsoon rainfall in southwest India during the last 2000 year AD. So the end member modeling analysis was performed on the grain size compositional data following this algorithm that we used the R software package, and the relative abundance of the coarser and finer end members describe the efficiency of overland runoff and the energy involved in the hydrodynamic processes. So in the Vegetation lake, we have got 3 end members. The end member 1 is actually represent the wash load transports with the overall runoff and internal erosional processes during the seasonal rainfall. The end member 2 that is actually indicates the well sorted delivery of fine sand, which must have resulted from the rill erosions and transportation by means of rolling of coarser materials. and the interventions of EM3 in the core, that in number 3 are occasional, and it correspond more to the event-related processes in the Vellani Lake. Compared to that, in the Vagamon Lake, the high latitude lakes, we have got the N number 1 and 2 in the Vagamon Lake are considered as the silt and fine sand size components, which is related more with the intervals and well erosion. And the coarser N numbers AM3 and 4 can be regarded as a medium to coarse sand-sized residues of the lateritic soil transported down the hill slope of the strong surface current. So besides these things, the intensity of rainfall and overland flow, the changes in vegetation in the catchment and lake water may also exert a strong control on the depositional processes. And another one important factor is that the lake in the lake is actually anthropogenic activities in the catchment. So the agricultural activities make a strong case in the wash load, where loose soils contribute fine sediments in the overland runoff deposits. So we have also founded this extreme pluvial flooding events, which are ascribed in the Vellani Lake basins from the dominance of EM3. Remember the 3 between 500 to nearly 1000 AD. So this intense flooding events suggest a strong and persistent rainfall during this event, this period actually. So these intensive rainfall and pluvial flooding events during the 500 to 1318 AD are in agreement with the strengthening of ISM during the medieval warming period and the MCA, medieval climate anomaly. So these, our record, we have actually compared with the regional rainfall intensity reconstructed from the other ISM records from the Central India, Northeast India, and the Arabian Sea. So in conclusion, we are these mean rain size variations of N-member scores in Vellani Lake indicate an intense rainfall and pluvial flooding during the 500 to 1000 AD and strengthening of ISM around this period, that is during the medieval warming period. And during the Roman warming period and LIA, there were decline trends on ISM precipitation, and the regional rainfall intensity reconstructed from this N number is actually in agreement with the ISM records from Central India, Northeast India, and Arabian Sea. Thank you.
Okay, thank you, Dr. Manoj. Now, this is the last poster presentation, and we presented by Dr. Tina Moore. With this work is also Dr. Vinita. The title of the poster is Hurdles and Breakthroughs of Integrated Reconstruction, a case study from Western India.
Hello, am I audible, sir?
Yes, yes.
Hello?
Yes, please go ahead.
Please switch to my poster, sir. I can't see my poster. Oh, I can see it here. Okay, yeah. Okay. This work basically focuses on how much close by paleo data sets integrate with each other or match with each other, even when interpreting the same idea. In this case, we are studying rainfall or humidity information studied in different varied geochemical or biogeochemical proxies. We can see we have done about 4 or 5 such groups of papers in Western India. Here only 2 of them are presented. Firstly, the mainly marine sites represented as A, they show in the west, that is the Limmer et al. Data set showing integrated geochemistry interpretations, and on the right of A site, A region, that is the Gruber isotope data sets from Azharuddin et al. 2017. They are very well correlated, even when they are very far from each other, and of different kind of analysis. But if you go slightly more inland into the B region, you can see that there are 4 sites very close by in a related Kutch Run area. These sites are these data sets are taken from Basu et al. 2019 for 4 and 6, and 5 and 7 are taken from Khonde et al. 2017. These are very related, very close by sites, and some of them are less than 50 kilometers apart. But even then, when they are compared, their variations do not match up. Khonde et al. Have used Khonde.
Hello, Trina, we are losing your voice. Hello, Trina.
Trina, you are not audible.
Trina, you're not audible. I'll just call her. She could have just come to the room.
Differences in the proxies, but it is the things which need to be taken care why the land area is not matching with each other. I will not go to details right now, and as mine is the last presentation in this thing, I invite everybody to connect to me on Trinabos by GTalk or any other means for any comments.
Okay.
Okay. Thank you. So this is the last presentation of this session, poster presentation. So I thank you all presenters for presenting and sticking to the time, and we are actually on time, rather there are still 2-3 minutes left. So thank you very much for your patience, and now I will hand over this for the next session to Dr. Vinita Padhyay.
Okay, there is no session. Can we just unshare this? Yeah, thank you. Thank you, moderators, for convening this session so well. Dr. Anupam Sharma and Dr. Manoj MC is here with me. So we are on time. We are exactly at 3, and I hope for the next 2 days we stick to such schedule for our oral and poster presentations. The posters were really nice, and I really enjoyed seeing all of them. And in the coming 2 days, there are several more, presentations of it. I just wanted to, say that because as poster is a visual form, and we have a space limit, so one has to adhere by the template that is sent to you. Many of them did, but 2 or 3 posters still they did not do their layout in the design in the template that we wanted. Because from here to present it becomes otherwise very difficult. So for poster presentations, because every time, we're not lucky to have oral presentations, and sometimes by choice we want to do poster presentations. So we really have to keep some things in mind, like, because there's less space, so we should see that the text is not much. We could do bullets, and we can utilize that space, putting up graphs and figures and our data sets. So that would really help us to design this, and we need to keep it very simple and very legible. Because even if you're not speaking and the poster is there in front of the audience, the audience should be able to make us, the story that you want to say or you want to present. So the format and the layout should be organized, and it should be very simple, and the language should be very simple. The color schemes here, it doesn't go like this. I like this color, so I'll be I'll use that. So it has to see that, like you're showing the posters of some other. So you have to see what color scheme are you using. So it shouldn't be very flashy, and it shouldn't be very subtle also. So these are the things that you need to keep in mind when you are doing a poster presentation. So but all these 18 posters were wonderful. So with these words, I thank the morning session moderators, Dr. Pradeep and Dr. Rajesh Agnihotri and Anupam and Manoj here. And I also thank Bob Wasson. He must be, he was there throughout the first session for his keynote, and all the 12 presentations in the morning and 18 just now, all the presenters, you are like, you were really great. It was really nice because of you. This session was there, was on the day one. So I thank you all. And tomorrow we meet at 9 o'clock because we start early because we have a keynote from Professor Peter Clift. It's a very interesting talk on the monsoon influences on Quaternary erosion and sediment transport, and he's giving in the Indus Valley. So I want you all to be there on time because he's talking from US, from the Louisiana State University. So, there is this time lag, and otherwise that is why we had to start early. But we'll be, ending early also, like 12 o'clock, I think we would do with the oral sessions. So please join me tomorrow for the day 2 of IQC 2022. Thank you so much. Bye. And have a very nice afternoon and an evening. Bye-bye. We need to copy this.